Hello, thanks for tuning in here. It's been a while since I posted videos, but today we're going to take a look at Firepower 7.x code. 7.0 and 7.1 is available now. And we're going to look at VPN load balancing configuration here, and I'll show you a demo here. Let's take a look at my setup here. So what I have here, ignore all the stuff on the side for now, is I have two Firepower appliances. There's a 4115 on the left with a logical FTD device because it's running containers, or excuse me, I'll call it a logical device, and also a 4115 number 2 on the right hand side with a separate logical FTD device, also doing VPN. Okay, and then these are the interfaces, and they're going to be doing load balancing. So load balancing, as you can probably know from the good old ASA days, is that you create a logical virtual IP on the outside, the public facing interface, and there's a connection profile or URL name that you assign to it. You connect to that, and that URL will actually load balance across these two interfaces or two appliances by the VPN load balancing software. And each appliance, of course, has their own name. So in this case, the one I have on the left is 4115c1.cisco.com/uservpn. And then the second one on the right is c2.cisco.com/uservpn. Okay, so you have to put these into the certificates, which I'll get to a little bit later here. And now, so I'll come back to the certificates side because that takes a little bit longer to explain. And then from a testing perspective, I'm just going to have a Linux client and then a Windows client connect and hit that VPN lb.cisco.com, and it'll get load balanced across the two here. All right, so let's talk a little bit about certificates now. These are just kind of screenshots. I'm using a Windows 2016 CA in my lab. So I generated the certificates with my Windows CA server, and then and you'll actually want the certificate for each of these devices to have the multi-SANs of each other, including the group URL here, that the virtual, I guess you call it, the share URL name that you're connecting to, all in a certificate. So in depends on what CA you use. OpenSSL is pretty easy to do, but for Windows one, this took me a while to figure out, is you got to create a certificate for each of these appliances showing this. It's got to have a DNS name, 3 entries, one for the 4115 VPN lb.cisco.com, and then the second one is 4115 C1 and C2. And so both certificates on each side looks pretty much identical because it's got both each other's, including that shared URL name here. And then if you want to do it with the Windows CA, the trick here is, this is the piece, the attributes that you got to put in here. You got to create the certificate request, cut and paste your CSR into here, select a web server template, and then put in the SAN, make that a little bigger, I'll use the next slide here, SAN colon DNS, and then the first name, and then you get the ampersand, then you get DNS, the second name, ampersand DNS, the third name. And for me here, I just put in a long string because I included the IP addresses in here. So really, in my certificate, I have all 6 fields, as you see here, DNS name and the IP address in my certificate. So right, so this is, I mean, that's really the trick you have to do. Somehow you got to get your certificate to include all the DNS names so that you don't get those pop-ups from the client side when they connect to either one of these boxes. All right, hopefully that makes sense to you here. And then the IP pool, I'll mention that, of course, since you're doing load balancing across both appliances, they have to have 2 separate IPs. You can't have the same IP address pool across both appliances. So in this case, I created a pool called 10.11.41. So that's the subnet for the first appliance. And then my second appliance is 10.11.42. Okay, so you have to configure that, which I'll show you in a second here. So hopefully this makes sense to you from the setup perspective. So let's go ahead and jump to the configuration of the FMC itself, Firepower Management Center. So if you log in, go into devices for RAVPN, you see here I created one already. There's a policy in here, and this policy has a connection profile called user VPN. And I'm doing for AAA, doing ICE radius authentication. So if you're one condition right now doing for VPN load balancing for FTD is you have to use radius, and in the future that'll probably get expanded to include SAML, but as of today it's radius, and it's okay. And then if you drill into that, configuration is pretty simple. I have a group URL connection profile. My group policy name is in here, and you can see if I edit that group policy, I'm just doing SSL, and then I pick IP address, assign my IP address pool. Now you see here there's one IP address pool that I told you, it's 10.11.41, but again, I can't have the same IP address pool for across multiple appliances, right? So I initiated, edit this, an override. So my first box gets 11.41 subnet, and then my override says my second box, my C2 appliance, gets 11.42. So this is how you sort of assign different address pools. And if you have a third box, you do an override for the third box. And then you got banner, DNS, that's just put in my DNS server, my domain. Actually, I'm not doing split tunneling, doesn't really matter. Everything I just left it as default, so it's very, very plain, very simple for you to get started here. So if I go to the next tab for AAA, again, I'm just doing AAA, doing radius authentication, and so it's the same for all. And then the third alias here, I have an alias name, user VPN, and again, the URL here is the same thing, right? Because it's two separate boxes. You can't have the exact same URL. So I have one in here, 4115c1.cisco.com/user VPN. Then I have an override. Let me see if it shows you in here. Actually, it doesn't. So we can take a look at it by, if I go to my objects page and show you what I created in my URL here. Yeah, this is the C1, so you can see here 4115c1.cisco.com user VPN. But again, I have an override indicated by the 1 number. And this override just says for my second appliance, my C2 appliance, it's 4115c2/user VPN. So you put that in here. This gets applied across both appliances. Okay. All right. So if we go back to VPN, that's sort of pretty much it. Now, if I go back into it there, access interface, you'll have to assign your CA. So I have to say tie this to my trust point, which is my Windows 2016 root CA. And I added my Windows CA in here pretty easily by going into, again, back to the object page that I did earlier. And if I go to PKI for certificate enrollment, all I did was downloaded the CA certificate from my Windows 2016 CA, and then created add certificate enrollment. Edit this in here. Picked enrollment type of manual and pasted that 64 base code in here, the blob of began certificate and certificate right into here, and hit save. So now you imported your CA here. Okay, and hit cancel, and that's all I did. So now if I go back to my VPN, you'll see here that that's my Windows root CA, okay, for SSL, and if you're doing IPsec, you can do that here as well. And then on the advanced side, this is where you do actually configure the VPN load balancing, and that's not, look at this yet, I'll come back in a second here, so you can see after I talk about certificates. So let me go back to certificates just a little bit longer here. Now, you also need to register each device with your CA, right? Have it signed certificate so the client will trust the appliance. My clients have to trust my Windows 2016 CA. So I've done this ahead of time already for my C1 appliance and C2 appliance, but to really understand what it looks like, all you got to do is hit the add button, and then I'll just pick another separate appliance that I have in my lab here, like a 3120 as an example. And then I go ahead and pick, I'm going to enroll with my Windows 2016 root CA. And so I'll hit add here. So now I am sort of associating that appliance with that CA, and it'll give me a chance. You can see here, identity certificate import required. So now I need to generate an identity certificate signed by my root CA for this appliance. And all you have to do is click on here, generate the CSR, that's fine. And wait for this to generate and copy this blob into your Windows CA. And then here, I'll just kind of walk you through here. Okay, and then request a certificate, 64 here, and cut the blob into here. Whoop, I guess I didn't cut, but you cut the blob into here, pick your web server template. I created one called web server number 2, and then put the attributes. Remember that I showed you the DNS colon or SAN colon DNS equals the name, the SAN field that you want to build in here. And then you submit and you'll get a signed certificate. And then once you get done, you go back to your configuration and browse identity and just import that certificate, that signed certificate back in here, and you're done. So I did that. So I'm going to ignore this for now. Actually, I'll delete it. I don't need it. And so that's how I got these two appliances configured or signed with the certificates. Pretty straightforward. And you can also verify, right? Like my C1 appliance here, my identity after it was signed, you can see here it's issued by my Windows 2016 root CA in the lab, and the name is 4115C1 there. Okay, so that's it. So that's it for certificate. So you just got to get past that part to get the certificates right before we enable the load balancing here. Now, I'll show you one more thing here from a device perspective. I have two FTD devices, 4115C1 and C2, and they got their interfaces. I'll just show you in a second here. They got their interfaces inside, outside, configured, routing, all the standard setup stuff. So there's really nothing crazy here. Now, so let's go back to RA VPN. So our appliances have been set up and our policy has been set up. So now let's go ahead and look at load balancing here. So I'm going to go into the advanced tab, and the load balancing feature is what you want. So you have to enable load balancing here between the members, and you can click on setting here. You can go ahead, by default it's off, but you can send FQDN to the peer device instead of IP, so that when a request comes to your main box, it'll redirect it by FQDN instead of IP to the other box. And turn that on because the client will trust the name of the certificate or FQDN on that certificate, so that minimizes the pop-up here. Okay, so turn that on, and then you'll have to create, as an example, a group IP address, right? This is the one that all your clients connected to. That's the virtual IP. And then you can also put in the IPv4 or IPv6, and then you specify the communication zone. That's the interface that these appliances will communicate to each other to form the VPN cluster. And so in this case, I'm using my in zone or inside interface zone, and this is by default port 9023. You can pick whatever you want, and I also enable IPsec encryption for that communications channel across the inside interface or zone. Okay, so enable all this, but that's your virtual IP. And then now you go ahead and just enable the participating devices that enable VPN or non-VPN. So I want to make sure I can load balance my clients across both of them. So I'm going to just go ahead and enable one for now, just to enable the load balancing. Okay, so that's been enabled, and let's go ahead and take a look at my client. All right, so you can see here, this is my Linux Ubuntu box. I'm going to go ahead and connect to 4115 VPNLB.cisco.com. Right, this is controlled by my DNS server, and so let's go ahead and take a look at a couple of these settings. So right now, I'll fast forward. You can see here my 4115C1 appliance does not have any VPN clients connected to it. Okay, and same thing with my other box 4115C2. There are no clients connected to it. So let's go ahead and initiate my connection. I'm going to hit connect. And then my username is Tom. I'm going to connect, and bingo. Now you can see that my AnyConnect client has connected, and I got an IP address of 10.11.41, which is the first appliance, the 41 appliance there. And so if we go ahead and take a look at this now, and we see that Tom just connected with an IP address of 10.11.41.15. Perfect. And then my public IP, okay, that's the appliance there. It doesn't really matter. So that's my client IP. So now let's go ahead and try my second client here. But before that, I want to go back to my Firepower appliance, and I'm going to try to enable the second. There you go, my second appliance. Hit save, and I'll deploy this. We're done with deployment here, so let's go ahead and take a look at our configuration, or I'm going to try the actual client. So let's go back to my Ubuntu. I'm still connected. Let me look at my Windows machine. There we go. Now it moved over to the 11.42. So if I go take a look at my sessions, so here this is the Linux box Tom, right? It's still there. Okay, Tom is still there. And now on this side, well, look here. Now it's Spike. This is the second user. My Windows 10 user is 10.11.42. So it load balanced across both boxes there from a VPN perspective. Now, if you want to take a look at some VPN load balancing information, we can run some commands. Let's show VPN load balancing. Here we go. So you can see here on the 4115C1 appliance itself, the 237 IP, that's its outside information. It's actually it's the backup. Versus if I take a look at the right-hand side here, show VPN load balancing. So the second appliance, C2 appliance, is actually the master. So how do you know which one's ever going to be master or slave? So there's a little bit of a trick here, meaning that if you go back to the configuration, let me go back to the configuration here. And so earlier, right in this page here, right there, so there's a priority that you configure. So the higher priority that you configure here in the device participation section typically will determine that unit to be the master. The higher the priority, the higher likely it'll be the master. So there are some specific use cases that sometimes it doesn't, but generally speaking, it will. So there's a little math algorithm that gets calculated to determine which appliance is the master. So you sort of can play around with these appliances. So, and all this means is that if the C2 appliance ever goes down, the C1 will take over, because it'll wait 20 seconds for some hello packets on the communication channel and things, and if it's not there, it'll resume the master responsibility there. Okay, so anyway, hopefully this is helpful to you from a VPN load balancing perspective, and if you have any questions, send me provide some feedback in the chat session or comment below, and we'll go from there. All right, thanks for watching. Oh, one thing I forgot to mention is how do you monitor the users without having going to the CLI or SSH is what I did here. You can actually go within FMC, and in my version, this is sort of an experimental version here. Not really related to VPN, it's just for other features. It's one of these menus, right? So for me, it's integration, and you go to users and active session. So earlier version might be in a different menu here, but it's users and active session. And you can see here that I have user Tom and user Spike that logged in via VPN authentication, right? And these are the IP addresses, 41 subnet, 42 subnet, and they came in on these appliances, C1 and C2. So yeah, so that's a way to look at it through the FMC UI. All right, thanks again.